Welcome back. This is lecture 2, part 3. So in this part, we will just do more modifications in our data set. So we will just play with variables, we will play with data sets, we will create new additional variables, we will summarize our data files and variables, and let's just go with this. So last time I just showed you how to activate existing data files within the R session. So remember that empty cars is one of the data sets that is available in R. So in this case, I'm activating the empty cars and I'm just seeing the head function. I'm using the head functions to print the first 6 rows of my data set. So basically, head is a really nice function. So because whenever you install or import or activate some data files, you can preview the data files by using the head function. So head function, as you can just see, printed first 6 rows of my data set. So I can see all the variables and I can see the first 6 rows, the corresponding values. Everything looks normal. And what I will do is that now I will just show you how to choose particular columns and rows in our data files. So because sometimes these data files will be quite big, and that's why we don't need to just take a look at all the variables, or we may need to just choose particular columns and rows rather than playing with all the rows and columns at the same time. So let's say that I would like to just choose the MPG column and I only want to print that one. So using the $sign empty cars $MPG creates a bridge between this data set and this particular variable within that data set. So in this case, empty cars $sign MPG will give me the MPG variable within this empty cars data set. So I will just run this one, and as you can see, all these values now they are printed on my console. Or you can just print multiple variables all together by putting their names over here, MPG, CYL, and disp. So let's just print multiple variables. So rather than seeing only some part of the data set, I'm just seeing only 3 variables in this case. Or let's just say I would like to print these variables but only the first 3 rows. As you can see, anything that you just define before the first comma over here, they define the rows, and the second part right after comma, it defines the columns. So in this case, I would like to print the first 3 rows of my data set and only for these variables. So let's just print the data. First 3 rows of my data set, because that's what I specified, 1, 2, and 3 is a sequence. And I only just chose these 3 variables and I will like to print them rather than everything in the data set. So that's how I can really just really shorten my data set or view some parts of my data set, some rows and some columns rather than everything. There are also different ways of viewing and previewing the data. So for example, you can use the view function and that will open up a spreadsheet like table over here, which is really nice. So you can just see all of your values and variables at the same time. Or you can use the head function like we did before. Or you can use the tail function, which prints by default the last 6 rows of your data set. So the same data, head prints the first 6 rows, tail prints the last 6 rows. Or you can just define how many rows you want to print in head and tail functions by defining a value. For example, I would like to print the empty cars data set, comma, and how many rows do I want to just see from the top. So 3 rows. This will only print the first 3 rows of my data set. Or similarly, I would like to print the last 4 rows of my data set. So I use the tail function and I specify 4. It will give me the first 4 rows of my data set. A couple of other important useful functions. The first one is again the dim function. It gives you the dimensions of your data set. So if I just run this, it shows me 32 and 11. So that means my data set has 32 rows and 11 columns. So it gives you the number of rows and columns respectively. SDR stands for the structure of the data set. So this is a really useful function to see what's inside your data and what type of variables you have. But if I just run this SDR for the empty cars, and as you can see, the summary just says empty cars is a data frame with 32 observations and 11 variables, which is really nice. So I can see the summary. These are all the variables in my data set, and it says these are all numerical values, and it even just prints some of the values over here so you can see the beginning of those variables in the data set. Alright, so before we just move to more complicated analysis or modifications in our data set, remember that now I would like to use the pipe sign, but if I just run this, it will give me an error message because it says this function cannot be found yet. So right now, remember the dplayer and any other function package that I would like to use, I have already downloaded them, but they are not active in my session yet. So what I will do is that I will just create a library statement, and I will just call both functions again. Now I will just run them, and this will activate both of the packages again. Now the following code should just work anymore, because not only I want to use mutate, I'm also using the pipe, so these two packages will give me all the functions that I need. So now in here I'm just using the empty cars data set using the pipe into mutate function, and I would like to create two different data files, two different variables within the same data file or data frame. I call them AM2 and VS2. So, and I'm using the recode function to recode this AM value and the VS value. So in this case, based on my data set, I know that these 0 and 1. So instead of 0 and 1, let's just create a data file that 0 corresponds to automatic and then 1 corresponds to manual, so that this information comes from the help page of empty cars. And I also want to just recode this VS variable, either V-shaped or straight. So again, I got this information from the help page. So now I will just run this, and this will just create a new data set, and I'm overriding my existing data file by saying that do all of this and then overwrite this empty cars data set. So let's just run this and then see the changes in our data set. So all the variables that I previously had, so they still exist in my data set. I also have two additional variables based on the recode function that comes from the dplayer function. So dplayer package. So I just created AM2 and VS2. So instead of 0 and 1 in AM, now we are seeing automatic and manual. So there's a transmission. And we also created another variable VS2. So instead of 1 and 0, we are just seeing V-shaped and straight. So basically they just combine, they just correspond to the VS column over here and AM column over here. Alright, so let's say I would like to subset my data. I would like to choose cars that have automatic transmission and the horsepower is larger than 70. So in this case, I'm using the filter function from the dplayer package and then pipe sign again from my other package over here. So I'm just using the empty cars data set again, data set that we already have. I'm using the pipe to send this data set into the filter function, and I'm just creating some conditional statements. This double equal sign will create a conditional statement based on what I want. So I want the AM2 variable to be equal to automatic, so that's why I just use double equal sign. And I just use the and sign over here. And then my second condition is that the horsepower should be larger than 70. So, and I'm this time, rather than overriding the empty cars data set, I would like to just rename this as empty cars underscore 1, so that I don't lose my original data file. So let's just take a look at this empty cars underscore 1 data set. Now this new data set that I printed has only the automatic cars, and the horsepower is always larger than 70 because I filtered out the other cases that do not match these conditions. So the filter function creates this conditional statement to select different rows. And I also want to show you a different function, which is select function from the same package, dplayer package. It also selects columns. So we can use filter to select different rows, and we can use different columns using the select function. So in this case, I would like to create a new data set. In this case, I'm just using the same filter as before. So use the empty cars data set. The pipe sends it to the filter function, and I'm creating my conditional statement for selecting the rows that meet these conditions. And I want this outcome of this process to be sent using the another pipe sign into the select function. And I would like to select only these 3 columns rather than everything in this data set. So let's just see how our empty cars underscore 2 data set looks like. As you can see, not only I got rid of all the additional rows that do not meet this criteria, I also got rid of some additional columns because I only selected MPG, CYL, and DISP columns in my data set, and I saved it as a new data file. So this is how we are going to filter out some cases and create alternative data files out of our existing files in the following activities that we will just do later on. So now let's just take a look at some functions to summarize our data files. So one important function in R that I use often is the summary function, and summary function gives a summary, or like a really brief summary of all the variables within a data set. So if I just run the summary empty cars, so the summary function, it summarizes everything in the empty cars data set, and it gives me all these statistics. So it says these are the minimum values, the first quartile, median, mean, third quartile, and maximum values for MPG, and I will see the same statistics for all of the numerical values. Whenever the variable is a character variable, and as you can see, you will just see this, the length of the variable, class is a character, and a mode again is a character. So it's not going to be any numbers because these are just characters rather than numerical values, because these are corresponding to these 2 additional variables that we created. We can also create manual summaries, which I really use quite often, because the summary prints some useful information, but sometimes we need specific information rather than all the first quartile or third quartile or maximum minimum. So let's say I would like to summarize my empty cars data set. I would like to find the mean MPG, standard deviation of MPG, minimum of horsepower, maximum of horsepower, and how many cases I have in my data set. So I'm using the empty cars, using the pipe to send the data set to the summarize function, which comes from the dplayer package. And now I'm just defining new variables, mean underscore MPG, ST underscore MPG. It goes like this, and these are the values that will match up to those new variables. So I want to find the mean of MPG, and I save it as mean underscore MPG. I would like to use standard deviation of MPG, and I save it as ST underscore MPG, and it goes like this, minimum maximum values. And N function within this dplayer package gives us the N counts. So if I don't specify anything over here, it will count things. So let me run this, and at the end we will just see a nice summary function. Mean MPG, standard deviation of MPG, mean horsepower, maximum horsepower, and how many cases do I have? It is 32. But most of the summaries are useful whenever we just use summaries by certain groups, because this summarizes the entire data set, which is good. But at the same time, we may want to categorize or see the summary statistics by certain categorical variables. So in this case, let's just assume that I would like to use this AM2 and VS2 variables that we have already created to summarize the data set based on mean, MPG, standard deviation of MPG, and N counts. In this case, I'm using this group underscore by function to create a categorization in my data set. So this sends the empty cars into group by function, and group by function splits the data set based on these two categorical or character variables, and the summarize function takes the output, again sent through this pipe. So summarize takes the output of the first two lines and finally looks at the MPG, standard deviation, mean MPG, standard deviation, MPG, and N counts by these variables. So now our summary function is really nice because it just shows us that this is AM2, this is VS2, these are all the combinations of these two grouping variables, and these are the mean MPG values, standard deviation of MPG, and how many cars I have that meet each of these categories. So for example, I have 7 cars that have automatic and automatic in this category and straight in this category, and the mean MPG and standard deviation of MPG are these values. And again, I just see the same statistics again and again, all possible combinations. Automatic straight, automatic V-shape, manual straight, and manual V-shape. So that really allows us to summarize the data by these two variables, but again, the values that I'm interested in over here, but by these two categories, 4 categories basically. Another function that I typically use in summarizing my data files is the skim function, and the skim function comes from the skimr package, which is really nice for skimming the data set and then getting a quick overview of what's available in it. So I will install and activate the skimr package over here. And next thing that I will do is that I would like to use the skim function from skimr package, and I'm just typing my data set name either with or without quotations. I can just make the quotations around here too, so they are kind of equivalent. So now let's just skim our data set and then see the overall summary. So in this case, the skim data file just says we have empty cars, and as you can just see, just assume that it is the overall summary. So it is complete, minimum 6, maximum 6. It doesn't mean much in this case, but let's just see it one more time without quotations. Now it just assumes that this is a full data set. So, and I'm just taking my statement back. So most of the time in functions, just using the quotations, they are equivalent. Like in this case, either I can just use this or just this. But in this case, in this particular function, I would like to just type the name of the function without any quotations. Otherwise, it will assume that it's a variable rather than a data set. So skim empty cars will summarize my empty cars data set. And as you can see, there's a really nice summary. It says I have 32 observations, 13 variables, and here are the variables that have the character feature. They are not numerical, and these are the numerical variables that I have in my data set. And here you can just see how many I have complete. I don't have any missing data set in this case, and complete are the same for that reason. I have mean, standard deviation, again different percentiles, and I have a simple histogram at the end, so which is quite handy to see the distribution of the data file. Although it's not really big or really visually appealing, it still gives you an idea. For the character variables, I only just see the N count, so it says again I have 32 variables, there's no missing, so that's why the 32 complete and 32 N, they are the same. The minimum maximum, they don't mean much in this case because we only have characters in this case, not numerical values. The only thing that I find useful over here is that it is how many unique values I have in each of these variables. It is 2 and 2, because again, remember, we just defined 2 variables for each, either automatic or manual, or V shape and straight, like in here. So that's why it just says we have unique 2 values for each of these variables. And I can also just use the group by statement that I just used before to create a summary by groups, so which is quite handy in this case. Let's just do this. So right now my summary is the same summary as before. However, as you can see, the summarization is done by these 2 categorical variables that I have, and you will every time just see the same summary files, same summary statistics, but this time by 2 categorical variables that I just use over here. And as you can see, you will just see all the combinations: automatic straight, automatic V-shape, manual straight, and manual V-shape. So, and these are the summary statistics for all of them, and the same as histograms. Finally, so let's just say that we would like to remove some variables from a data set. So right now, let's just see one of the variables. WT is a column in our data set, and I would like to remove this column from my data set and then just use the remaining variables. So whenever I assign a null to a certain column in a data set, that gets rid of that column from the data set. So let's just assign null to WT column and then preview the data set again. So in this case, as you can see, that WT variable or column, it's gone. Previously we had this data set with WT over here. It was one of the variables, but now our new data set doesn't have that column anymore because we assign null to that value. Another common problem in data science is the missing values. So in R, there are several ways of seeing missing values, but the most common way is NA. So whenever you see NA in a data set in R, so it means that there is no value for that, there is no specific value for that particular cell, so it is missing. So let's say I would like to modify certain values in my data set, and I would like to assign missing to them. So in this case, I'm choosing the MPG variable from my empty cars data set. So I'm just using empty cars $MPG. First 3 values of MPG I would like to assign NA, so that will make my first 3 values under MPG missing. So let's just do this and let's see how the data changes. Alright, so now I just assign NA to first 3 values. So basically my first 3 values are now missing in the data. So there is no valid values for those, and whenever I do certain statistics for this, now I need to be careful. So let me just show you an example. So right now we have some missingness under MPG, and I would like to summarize my data set. I'm using the same procedure as before, using the summarize function, and let's just run this and then see what happens. So since I have some NA values or missing values under MPG, so the summary file returns NA2. So because R doesn't know how to deal with NA unless you tell it what to do. So that's why what I need to do is to tell R that I have some missingness in my data set, and remove this missingness before you do any calculation. So for example, mean function has this na.rm. So na is the missing, na.rm means should we remove the missing values before we do the calculations, and saying true to this option within the mean function and standard deviation functions. So will give us the summary statistics without those cells, so we are not going to get NAs anymore. So let's just run this. And as you can see, the same procedure, the only change that I made is this na.rm true, meaning that if there's any missingness in my data set, remove it and calculate the statistics based on the remaining values. And in this case, R really returns valid summary statistics for me rather than just a bunch of NAs. So this is something to be careful about whenever we deal with big data files, because most of the time in real life data files have missing values. With missing values, if you ignore these options like na.rm or other statistical operations that we will just do later on, if you don't tell R what needs to be done with the missing values, typically it will result in NA or other invalid values, which will eventually distort other operations that we will do later on. So missingness is something to be careful about, but in lecture 3 we will talk more about missingness and how to count missingness, how to deal with missingness, how to see like missingness would be a problem for our analysis and things like that. But it is for now. All I can just say is that, or emphasize, is that missing values, they exist, and whenever they exist, so they create issues unless we really specify what needs to be done with this with these missing values. All right, this is the end of my summary for this part. But what you will do next is that, so I just added this list of packages that you need to install before you begin any of the exercises that you will just follow, or any of the lectures that you will just watch in the remaining part of this course. So I just listed all of them. So basically what you will need to do is that select all and make sure that you have internet access and click run. All of these packages should install without any issues at the end. So once all the packages are installed, and the next option is to activate the package, the complementary package for this course, which you are installing over here using my GitHub account. So once this package is installed, so you will just see that each lecture will come with several exercises, and each exercise can be activated using this run_exercise function using my package. So once you activate my package, these are this adsur or adsar package, so it stands for the name of our course, and applied data science using R. So once this package is active, just run this run_exercise function and specify which lecture that you would like to take a look, and it will open some exercise questions for you, and you will just take a look at those exercise questions. They may look like an HTML files, but they are actually using your R codes and operations, so you will be able to answer some questions and then do some R exercises after each lecture. So once you finish this video, so you can definitely install all the packages over here, and your next goal would be just to activate the package and just run the exercise for this lecture and start playing with R. So I'll see you in the following lecture, lecture 3.